This video is going to go over section 4.5, which is titled Observational Studies and Experiments. So we're going to go through the definition of both of those and some of the properties, and then examples where we're kind of classifying between the two. So an observational study is a way to collect data where we watch individuals and measure variables of interest, but does not attempt to influence responses. That means that I don't give anything to the people that I'm studying. I don't change anything. It's just I'm collecting this data via survey or observation. An observational study can happen retrospectively, meaning that I use data from an event that already occurred, or it can happen prospectively, which is where I track the events of individuals into the future. So it's collecting data over time. So data that already was, data from something that already happened, or data from things that are happening currently. So those are both observational studies, just different types. So in this example, we've got many golfers wear wrist bracelets containing magnets because they claim the magnets improve balance and the length of the shots played off the tee. A golfer would like to determine if the claim has merit and proposes two methods for collecting data. So we're going to identify which one of these is an observational study. So the first one is, as golfers approach the first tee, give some golfers wrist bracelets with magnets and some golfers wrist bracelets without magnets. During the round of golf, keep track of the length of golfers' shots. So if we think about what's going on, the people conducting the study should not attempt to influence responses. So by them interacting with the golfers and giving them a bracelet, this is not an observational study. If instead maybe they were just looking at golfers approaching the tee and seeing if they had one of these wrist bracelets on, and if they did, collecting data about them, that would be an observational study. Okay, so if they're observing, oh, that golfer has this bracelet on, I'm going to record their the length of their shot. That would be an observational study, not giving them a bracelet and then recording the data. And then method 2, contact golfers who have purchased wrist bracelets with magnets and ask them to provide information about their shot length. So this is an observational study. If we think about it, since they're asking them about their shot length because they've previously purchased, this is a retrospective example. Okay, so again, for method 1, it's not an observational study because they're influencing the responses by giving the bracelets. If they were just observing, oh, that person has a bracelet, I'm going to take their data. That person doesn't have a bracelet, and so on. What method 1 actually is an experiment. So an experiment deliberately imposes treatments or conditions to individuals and measures responses. So I'm influencing what's going on by imposing treatments. A treatment is a specific condition applied to the individual based on random assignment. So it's important that there's random assignment involved in experiments, whereas with an observational study, I don't have to have a random group. So in this example, a clothing company is considering a new installation for winter coats. To collect customer satisfaction data on the new installation, the company is considering two methods. The company offers first 50 employees who volunteer to try out a coat with the new installation. They will report their satisfaction level after 1 month. At the end of the month, the 50 volunteers describe their satisfaction. In method 2, the company takes 50 volunteers, then randomly assigns them 25 of them coats with the new installation and the other 25 coats with the current installation. All volunteers wear the coats for a month and then describe their satisfaction. So this idea that this treatment was applied with random assignment, this is an experiment. So method 1 is not an experiment. And if we think about it, it's not really an observational study either, right? Because they're giving a treatment in some way. The big idea about an experiment is that there should be 2 or more groups based on those treatments. Okay, so we should have 2 or more groups when identifying an experiment, that's kind of a key indicator. The next thing is a placebo. So placebo is a treatment that has no active ingredient, but is still otherwise like other treatments. It allows individuals to not know if they've received the treatment or not, and it creates a baseline group for comparison. An example of a placebo would be in that method 1 for the golf, the wrist bracelets without magnets, that would be a placebo. Okay, so this is an experiment because of the two groups. One has a placebo, one has the actual wrist bracelets. So that's why it was not an observational study. Next one we've got is confounding. Confounding is when two variables associated in such a way that their effects on a response variable cannot be distinguished from one another. So confounding variable is ultimately an extra explanatory variable. Okay, so it's an explanatory variable that you weren't intending. So an example of a confounding variable would be in this situation. So an auto parts store offers a fuel additive that claims to increase the vehicle's gas mileage. So the fuel additive is the explanatory variable, and then the gas mileage is the response variable. The additive is poured into a vehicle's gasoline tank after the tank is filled. To measure the claim, a store offers a free bottle of the additive to customers who drive SUVs, and then provide information about their gas mileage in the store website. Customer argues the type of vehicle, so think about the fact that we're looking at SUVs, can be a confounding variable in this study. So which statement best describes the effect of the confounding variable? So what is it about the type of vehicle that could influence the gas mileage? So because vehicles of different sizes may respond similarly to the additive, it should be easy to conclude whether the additive improves gas mileage. So this is saying that it shouldn't have an effect, right? So this is saying that it's not a confounding variable, okay? And so let's kind of read through and see if we agree that, essentially disagree with this customer. So then it says, because vehicles' different colors may show differences in gas mileage, the additive may improve gas mileage in some vehicles, but not others. And realistically, does the color really influence the gas mileage? No, so that's definitely not an answer. Because the owners of different types of vehicles may choose not to use the additive, those vehicles will show an improvement in gas mileage. Ultimately, if the owner doesn't use the additive, do you think that they would go to the store website and fill out the survey? Because I don't. So I don't think that would be what the customer is talking about. The last statement is actually very similar to the first. So because vehicles of different sizes, right, may respond, they're saying, differently to the additive. It may be difficult to conclude whether the additive improves gas mileage. So this one said it would be easy. This one said it would be difficult. So one thing to think about in terms of gas mileage is that the size of the vehicle does influence gas mileage, right? So in general, a smaller vehicle with a smaller engine is going to have better gas mileage than a larger vehicle with a larger engine. And so this statement is the more true one. So that the size of the vehicle will influence that response variable of the gas mileage. The final thing they talk about is components of experiments. So they give several components. Let's first just talk about experimental units. So an experimental unit is an object which treatment is randomly assigned. If the experimental unit is a human, they're called subjects rather than experimental units. So in this next example, we're going to identify the different variables and the experimental unit. So let's start with the experimental unit. So the experimental unit is the object in which the treatment is applied. A researcher conducts an experiment using 10 loads of white shirts with similar stains. The loads are divided and 5 of the loads are washed with the name brand detergent. So the 10 loads of white shirts with similar stains, that's the experimental unit, right? That's what our treatment is being applied on. So our experimental unit, which is D here, is the 10 loads of shirts. 5 of the loads are washed with name brand detergents, while the other 5 are washed with store brand detergent. So the type of detergent then is what we're changing. So that means that that is my explanatory variable, right? So that's the treatment that I'm putting on. That's my explanatory variable, is the type of detergent. Volunteers are asked to assess the cleanliness of the shirts. The cleanliness of the shirts then is my response variable. That's what I'm looking for. So B is for my response variable. So I answered A, B, D. All that's left is the confounding variable. So remember, the confounding variable is something that the researchers might not have thought about that also has an influence on the response variable. So something else that could influence the cleanliness of the shirt. It's usually like an extra explanatory variable. So if we look at this, depending on the type of machine that's used, if I have a newer machine or a more efficient machine, right, that can have an impact on the cleanliness of the shirt that I might not have a custom for. So the machines used to wash the shirt could be a confounding variable. We could fix that by washing these shirts in the exact same washing machine every time, right? So as long as the loads are all washed in the same machine, that would eliminate the idea of a confounding variable. The other two things are factors and levels. So a factor is an explanatory variable that is manipulated and may cause a change in the response variable. So the factor is what we're manipulating. The level is the different values of the factor. So it's essentially the manipulations. So let's look at an example that describes that. So brand of popcorn instructs users to microwave for 90 to 120 seconds on high. A student wonders what the ideal microwave time for popcorn might be and designs an experiment to find out. The bags of popcorn are placed in the microwave for 4 different lengths of time. Okay, so he's using different lengths of time. And then 2 types of microwaves with different power capacities will be used. So they're using 10-second increments and then a 900 or 1,000 watt microwave. At the end of the experiment, the number of unpopped kernels will be counted. So remember that when we're thinking about this, the factors are like the big ideas, okay? And so the thing that we're changing, and then the level is what we're changing them to, okay? So the factor then is the length of time. The level of that factor is 90, 100, 110, 120 seconds. This one actually has 2 factors. The other 2 factors is the microwave's power capacity. Okay, and that only has 2 levels. It's either 900 or 1,000 watts. Okay, so again, think about the factor as the broader term. It's our explanatory variable more generally. And then the level is what we're changing within that explanatory variable, how we're manipulating it to create that experiment. So ultimately, big ideas here are that the observational study is where I'm not changing anything that's going on in a situation. I'm just collecting data about it. And then an experiment is where I'm randomly assigning people to 2 or more groups and providing a type of treatment, so I'm influencing the situation.